We are Space Exploration Alberta Robotics, a student club at the University of Alberta. Today we will be talking about making a vehicle for use on other planets, using our own rover as well as NASA's as an example. Life on Mars is a bit different than life on Earth. There are challenges that come with this extraterrestrial environment that need to be considered when designing a robot that will make Mars its home. Spear hopes to overcome these challenges. Traveling over Mars' surface means overcoming a lot of obstacles. Luckily, our rover has large inflatable tires. These tires are specially designed to drive over sandy, rocky terrain. They are also very squishy, so they help the rover bounce back up when it encounters drops, instead of just crashing onto the ground. To help the rover bounce even better, we added a suspension system using air shocks from a mountain bike. These have air inside that acts like a cushion between the rover's legs and its body. Another challenge is dealing with the surface of Mars, which is very loose because of how sandy and rocky it is. To allow our rover to climb up steep, rocky hills, we use treads on our wheels. These treads help grab onto the ground and help the rover push itself up the hill. Another thing to consider is that there's a lot of dust on Mars. To keep it out of our electrical components, we enclose them in a plastic box. The wires that power the rover's wheel motors enter this box through special openings called grommets. These grommets are made of rubber and let the wires come in but keep most of the dirt out. We also use duct tape to seal around the top lid of the rover to keep dust from getting inside. This keeps the computer boards clean and our rover's brain going strong. One other important factor to consider for robots on Mars, or even in space in general, is how they are to move around. The way this is decided depends on a lot of factors, including where it is and the tasks it needs to do. One really cool application is untethered or unrestrained robots that can move around the exterior of a space object like the International Space Station and perform maintenance tasks. Right now, this is not a reality, but could be in the future with the use of electroadhesion. Electroadhesion uses an electric field to create an electrostatic attraction. This is the same attraction that happens when you rub two balloons together and get them to stick. This is also the same attraction that's responsible for the shock that happens when you rub your socks against the carpet and then touch someone. These are just some of the things we need to do in order to make our spacecraft viable for space. We of Spear hope that our presentation helps demonstrate some of the many challenges space vehicles face.